This video is about CSI, the Container Storage Interface. Thank you for watching. So, what is CSI about, and why do we need it, and how is it being used? To answer this, we'll give an overview of CSI, offering lots of examples as we go. So we'll have a look at CSI, about the concept, how CSI operates, API design, the volume lifecycle, how is a volume being managed, driver examples, CSI features. We'll summarize it, and then we'll look into Red Hat Data Services, how this relates to CSI and how CSI is being addressed within Red Hat Data Services. CSI is about storage operations within container native environments. It's an API specification for the management and operation of container storage. It's also an industry standard container interface. So CSI is an API and a common methodology to address storage as an industry standard. It's an abstraction layer also to manage storage volumes within the container native environment without having to worry about complex underlying storage internals or specifics. The user story here is, I, as a developer, I don't want and I don't have to worry about all these internal storage specifics. So I can drive a car, but I don't have to be a gearbox transmission specialist to drive my car from A to B. I just want to have the functionality, but I don't need to know all these specific details. So let's have a closer look at CSI and how it actually operates. CSI by itself runs as a plugin, and that plugin has two major components. There is a centralized controller plugin that lives on the master nodes, and there are also decentralized headless node plugins which run on the worker nodes. The communication between these components is all done by remote procedure call, and it's done by gRPC. That's an open source implementation of the remote procedure call. This was used as an interface along with the minimal operational package requirements that interfaces need to have the RPCs as a primary focus of the CSI specification, which is the communication protocol between container orchestrator like OpenShift or Kubernetes and the plugins. And then it uses drivers. CSI drivers. Well, what's a CSI driver? That's actually a vendor-specific storage driver, which is compiled into OpenShift Kubernetes binaries. And to use that CSI driver, you need to have a storage class. The storage class needs to be assigned first. The CSI driver is then set as the provisioner for that storage class. And CSI drivers provide three main services. Let's have a closer look at these services. So the first one is identity. It provides the plugin name. It also provides the capabilities of the plugin. We'll dive into more detail later on here. And also about the status of the plugin, whether it's ready or not, available, etc. The second one is the controller servers. And the controller service is all about global cluster operations, but it can also be about external operations. For instance, operations that take place on external storage systems. And this is, again, all about cluster operations, and that's done by the controller service. And then the third one is the node service that actually is responsible for local machine operations. That actually handles the actions on the local machine, but also with regard to containers. So it takes care of mounting volumes, the bind mounts, etc. That's all on the node service. We'll have a look at the API design. It's a simple and compatible API design, which is for a broad variety of different storage systems. Block storage, file storage, raw devices, local storage, but also network storage like SAN systems, NAS systems. It can be pre-provisioned, like static provisioned volumes. It can also dynamically provision storage, and it can be about single or multiple writers. So this is all what's involved with the API design of CSI. Now we're moving on to the volume lifecycle workflow and the different volume stages. So the moment a volume is requested, we enter the starting point where a volume is created. And when that's done, then the next step is to publish the volume to the controller. And once that's done, there is a state named node ready. And once the node is ready, has the volume in place, that's the point where we create the bind mount, make that volume available to all nodes in the cluster. And this is named node publish volume. And then once that's done, then the volume is actually published. The bind mount has been realized. Containers are able to access the persistent volume capacity. The nice thing is it's a very simple process. So the reverse process is actually to clean it all up. So maybe you heard of this 90s song by Tony Braxton named Unbreak My Heart. And this is actually a similar thing. So now the volume was created and we are going to unpublish the volume. We're going to remove the bind mount. We're going to remove the volume from the node, and that's a controller unpublished volume. And then we get at the point that the volume needs to be deleted, which is the final step, and that's the finish point of the volume lifecycle sequence. Let's have a look at container storage interface driver examples. At this moment in time, there are over 100 drivers with a variety of different storage vendors. Of course, Red Hat OpenShift Data Foundation offers this capability and uses CSI. The same goes for Red Hat Ceph Storage. We'll dive into the differences later on here. Other vendors are AWS, Amazon AWS, Elastic Block Storage, EBS, or Google Cloud Persistent Disk, or Azure Disk, or NFS. And there is a big variety of all the well-known storage vendors that have these kind of capabilities. Also, VMware has this implemented with vSphere, and there are many other startup storage companies who also use this CSI API. The main important thing to be aware of here is that the capabilities depend on the driver features. So the CSI driver can have or not have specific features. The basic ones are to create and delete volumes, mount and unmount. But then when it comes to a little bit more advanced, it can be encryption in place. So it needs to be able to handle secrets or internal topology of a storage system. There can be maybe different tiers or different types of disks to address. And that's also something that can be addressed by CSI. There can be things like skip, attach, and detach, which is typically used with NFS volumes, because then you can skip steps. You don't have to create the resource first. You just want to publish a volume. You can skip certain steps there. You can get pod info amount, which container pod uses which persistent volume, that kind of information. Maybe information about the workload, that's important. Expansion of volume, snapshots, etc. Cloning of volumes. And these are more the advanced capabilities that CSI can or cannot have. Different things like capacity tagging, token request, it all depends on the capabilities of the driver and the backend storage. So having said this, persistent volumes can have different capabilities. There are basic capabilities, but also advanced and additional capabilities that not per se have to be in each storage system from each different vendor. So it depends on the driver and on the capabilities of the back-end storage. That defines which capabilities you as a user or a developer have. So to summarize, CSI is an industry standard for container storage. It's an abstraction to the underlying storage backend internal complexity. It's a common way to address container storage needs and the operation and management of the storage within the container native environment. And again, capabilities depend on the API implementation and backend capabilities. Having said this, CSI storage does not equal CSI storage. Well, what does that mean? Here's a cow. A cow is actually an animal that has 4 legs. Okay? But an animal with 4 legs doesn't have to be a cow. It can be a complete different thing and a different perception or implementation. So this is what I'm trying to say here. Same goes for CSI. Let's have a look at Red Hat Data Services and how we use CSI. First of all, Red Hat Data Services is all about simplified access. Having a simplified way to access your data, not having to go through a lot of stages to access, just consume where you need it. We're also offering a consistent experience. And that means on whatever infrastructure platform you're running on, you'll have exactly the same experience. It doesn't matter if you run on-prem or in public cloud or in a different public cloud or hybrid cloud, you will always have the same consistent experience. And one of the things with OpenShift Data Foundation is that it is very dynamic at scale and it can run at huge scales also. So we make data accessible to applications across hybrid cloud, unlocking its power in new and many impactful ways. And this enables our users to practice innovation without limitations. Well, Red Hat Data Services, where does it fit? So you have a physical storage that's being consumed, and on top of that, we provide Red Hat Data Services. So Red Hat OpenShift Container Storage consumes raw disk storage to provide higher level services. How does that look? On the bottom of the diagram, you can actually see the raw storage devices, which can be local storage, cloud storage, SAN, or any kind of raw disk provider. This is where OpenShift runs on top of. And then that's where Red Hat Data Services sits. And while it consumes raw disk devices, raw block storage, on top of that, we provide uniform Kubernetes, RWO, RWX storage classes, object storage service, and a multi-cloud gateway functionality. Red Hat Data Services consists out of 3 major products that are being used to actually provide the services on top. One of them is Red Hat Self-Storage as the basic component. The other one is Red Hat OpenShift Data Foundation. Previously, this was named Red Hat OpenShift Container Storage, but now it's Red Hat OpenShift Data Foundation because Red Hat now focuses on data services instead of only being a storage provider. Another new component is Red Hat OpenShift Data Science, and that's related to Open Data Hub to be able to run AI/ML applications and those kind of things, all in the context of Red Hat Data Services. And with this, I'd like to thank you for watching this presentation, and I hope to see you next time. Have a nice day!